Hello everyone. So this is our letter combinations of a phone number, and it's quite a tedious question, and it's rated medium. So the premise is that there's a phone dial thingy here, and there used to be a time where keypad phones mainly operated on this to text and everything. So, but that's not relevant to us. All that is relevant is that given this mapping, like 2 is mapped to ABC, 3 is mapped to DEF, 4 is this thing, and 9 is this thing, we are basically expected to return all possible letter combinations that the letter could represent, return the answer in any order. So they'll give us something like this, a string, like 2 and 3. So for 2, we'll have ABC, and for 3, we'll have DEF. So what is the combination of uh, this and this? What is the combination of forming a string that is of length 2, that means of whatever length that the number of digits that they've given, and have 1 in this and 1 in this in that sequence, that exact order? Like the items in 2 must come first and the items in 3 should come next. So over here it'd be AD, AE, AF, BD, BE, BF, and CD, CE, CF. So this seems like a easy-ish, straightforward-ish question, but it's actually quite tedious. And like any Leetcode, there's many ways to do this, but I'm going to opt for a recursive solution because I think it's the neatest and most elegant way of presenting the answer for this. So what exactly does this solution entail? Um, Basically, in a recursive solution, we find a repetitive sequence that is adding whatever is in this new string to the result, adding whatever is in the new string, adding it to the result again and again. So that kind of sequence, that kind of repetitive sequence helps us, and that's what we'll be doing now. So before that, for this question, there's just no choice. We have to have the mapping, which is 2 is equal to ABC, 3 is equal to DEF, 4 is equal to GHI, G5 is this thing, and so on. Like we just have to have the manual mapping of this. There's no workarounds for this. So I just copied it to save time. So that will be our dictionary that contains the mapping. 2 is this, 9 is this, and so on and so forth. And next, what we can do is we can eliminate our corner case issues. In this case, if the digits is empty, like if uh, length of digits is lesser than 1, that means if it's empty, we just return the final array, which is here, fin empty, we just return fin. If it's not terminating, like if it's not basically less than 1, that means it's the normal case, which is like something like this. We need to find a way to iterate through each element, like each digit one by one, like the first digit, then second digit, then last digit, something like that. So for that, yes, you can do this for loop, but I'm going to use just a recursive way of going through the items. So how do I do that? Firstly, I need to have a different helper function. I won't define what it needs. I will just call it over here, and assuming I need to put digits over here. So this will be the input string. Maybe I'll say imp. Uh, yeah, I'll just say imp. Yep. And I need to find a way to terminate this early. So when do I terminate? So I need to terminate it. Like basically I will traverse through, like when it's 2, I will traverse through ABC. When it's 3, I'll traverse through DEF. And after I'm traversing and adding it to something, I need to terminate it at some stage. So before I get to what is the termination condition going to be, I'm going to create how do I get there. So how do I get there? First things first, I need to extract the first element out of it. Like I need to take out the first thing. So to take out the first thing, I'm just going to say starting, and I'm going to call this, and I'm just going to index. I'm going to use the indexing to find what's the first starting digit. And I'm going to convert this into a number integer. Not necessary, but it's just that my mapping is in integer values. Integer value to, so that's why because digits will be in string, if I extract the first character, it'll be in string. I convert that integer and I get a starting value. And from there, I'm going to get the array in which that I'm interested in. So in this case, 2, I need to get this. So for I in dictionary start. So dictionary start will be ABC in this case if it's 2. I basically call the helper function again. And the helper function will now have input, but without the first item. And it will have to keep track of the result. So result plus I. And that means our helper function needs to be updated everywhere. So result, okay, this doesn't have a result. This will just have a starting point, which is empty string. So empty string will come here and and it will add A first, and it will run the sequence again, whereby our input will now be 1 less, which will be 3. So input was initially 2. Input was initially 2, 3, 2, 3. And our starting was 2. After going through the sequence, our input has been slashed by this, and it's now 3. And I think it's now a good time to define what this is going to do. If input gets to 0, if input's length is 0, like len less than 1, then we can do something, which is we add the fine. That means the result is perfect already. We have seen all the combinations of it. The one and the result is possibly one of these things. So we just need to add this to our finale. So fin dot append result, and I think that is good enough actually. So so if input is lesser than 1, fin will append the result, and input is going to be like this. Okay, one thing that I want to point out over here, which is that fin cannot be accessed directly in the helper. We would have to have something called non-local fin. So this is to reference objects outside the helper function, but retain its value. Like we're not instantiating a new empty array every time we call helper. That would just be a never-ending process. So yeah, non-local fin will reference the fin that's outside, and it will append res, whatever our final output is, into this thing. And I think it should be okay already. Let's see. And we need to return fin. Whoops. Okay. Return fin. And let's see. Let's run this. So yeah, we got the answer. So basically we use the helper function to do our recursive process. We will take an input as 2, 3 at first, and we will extract the first element as start, which is 2, and I'm getting the string over here, and I'm doing a follow through the string, and I'm adding it to res, which is an empty string initially. So empty string plus A will be just A, empty string plus B will just be B, empty string plus C will just be C. And we're passing that into the helper function. So now the helper function's inputs are 3 and A or B or C, which will then go here, and starting value will now be 3. And for I in dictionary 3, which is DEF, we will have A already as one of the results. So A plus D, you get AD, and input will be 3, and we slash the 3 as well. So it'll just be empty string. So when we go here, when empty string comes here, it'll qualify for this statement, and hence we'll go to fin.append res. So what is res? Res is A plus D, which is AD, and AD is the first item over here. The order in itself doesn't matter, so we are lucky in that sense. There's not much of a more frustrating rules added to it. But I think in our current approach, we will get the same order as this. Like we will see all A's first, and then we will see all B's, then D, something like that, which is what we see here. Yep, we are getting the answer in the same order as what they expected us to get. Okay, maybe I'm talking too much. I should run the submit. What if there's some test case that I mess up later on? Okay, no, it's right. So this is my solution for what is the question? Letter combinations of a phone number. So some tricks and tips for this question is basically I employed the use of recursion to solve the question. I also employed the use of referencing a non-local object, and also some other minor minor optimizations that I did was because when I was testing out, my memory was initially not that great because recursive solutions might occupy more space. But I tried to shave off some memory space by making some optimizations like having the keys to be an integer instead of a string. And yeah, like this was an unnecessary time killer. And just some optimizations is that integer stores lesser space than a string, and some early termination to shave some time. And yeah, this is one way to do the solution. There are other ways probably, but hope you guys enjoyed the solution and learned something. And please give your feedback if you have anything, and I will take note and maybe revisit this question as well with another approach, like maybe iterative solution for this. So yeah, hope you guys enjoyed the video, and I'll see you in the next video. Bye.